Hi guys, welcome back. Don't do too much in opening, just get to the list. So the topic today we're gonna discuss is matrix inversion. So first we're gonna talk about the cofactors. So a cofactor is the number you get when you remove the column and row of a decided element in a matrix, which is just a numerical grid in the form of a rectangle or a square. The cofactor is always preceded by a positive or negative sign, depending whether the element is in a positive or negative position. So without any further ado, we're gonna get to the example. Here we got the matrix. So we want to find the cofactor of 2. To do that, we have to put blinders around the 2 and eliminate the row and column that contain the 2 as shown in here. We get the new matrix in here. After we have the new matrix that doesn't include 2, you can calculate the determinant or number derived from a square matrix. You can find the determinant by multiplying the diagonal numbers of the matrix. For example, from the last new matrix, we multiplied 3 times 9 is 27 and 6 times 4 is 24. So after that, we're gonna subtract the value of the second diagonal from the value of the first diagonal is 27 minus 24 is 3. So our determinant equals 3. So for the last step, we have to check the sign element. The element each 3 times 3 determinant has a cofactor sign determined by the location of the element that was eliminated. First, that we take a look at the signs of a 3 times 3 matrix in here. We get to know the position where is the 2 is, and we can conclude from there is 2 is plus position or negative position, and we can conclude that what the sign we have to put in front of the equals number that we get from the step before. So next we're gonna talk about the determinant of a matrix. So the determinant of a matrix is a spatial number that can be calculated from a square matrix. So the symbol for determinant is 2 vertical lines either side, like here. First, we're gonna see the example of determinant matrix for a 2 times 2 matrix. So here we get the 2 times 2 matrix in here. So the determinant pattern is determinant is AD minus BC. So it is easy to remember when you think of a cross like this. You can see in here. And for the example, you can see in here, it's really easy for the 2 times 2 matrix like here. The result is 14, just times it, and also we minus it. Next example, we can see in here, it's a 3 times 3 matrix. We can see here, we have the matrix, and we can find the determinant by doing this pattern. It is complicated, but here is the pattern. Also in here we can see the formula of 3 times 3 matrix, and for the example we can see in here maybe it's more complicated from 2 times 2 matrix, but I guess that we already knew this kind of determinant matrix, so yeah. So here we get the last determinant of matrix is 4 times 4 matrix. So here we get the pattern, also the formula. For information guys, if you want to search the highest number of determinant matrix more than 4, just use the matrix calculator because it can give you the best result. So next we're gonna talk about the identity matrix. It is the matrix equivalent of the number 1. Here we can see the identity matrix, 3 times 3 identity matrix in here. It is square, has same number of rows as columns. It has ones on the diagonal and zeros everyone else. Its symbol is the capital letter is I. The identity matrix can be 2 times 2 in size, or 3 times 3, 4 times 3, and many more. So next we're gonna talk about the inverse matrix. So the definition, the inverse of A is A to the power of minus 1 only when A times A to the power of minus 1 equals to A to the power of minus 1 times A is I. Sometimes there is no inverse at all. So here we can see the example of 2 times 2 matrix in inverse matrix. Well, for a 2 times 2 matrix in the inverse, the process is like this. In other words, we just swap the position of A and D, put negatives in front of B and C, and divide everything by the determinant, which is AD minus BC. So you guys can see the example in here. Here we get the result in here. We just follow the step, the process like we see from the last step. So we can see the inverse is like this. Next topic is non-singular matrix. So a square matrix that is non-singular, example, one that has a matrix inverse. Non-singular matrices are sometimes also called regular matrices. A square matrix is non-singular if its determinant is non-zero. So for example, you can see guys, all the matrix in here. So guys, if you want to search for the determinant in here, you will find that the determinant is non-zero, and that is called the non-singular matrix. Next, we're gonna talk about singular matrix. So a square matrix that doesn't have a matrix in first. A matrix is singular if its determinant is zero. For example, we can see again the matrix in here, many matrix. So guys, if you search determinant all of this matrix, you will find the determinant of this matrix is zero. So that is called the singular matrix, different from non-singular matrix. Non-singular matrix is the result is non-zero, but singular matrix the result is zero. The last topic is square matrix. So square matrix, an n times n matrix is said to be square matrix of order n. In other words, when the number of rows and the number of columns in the matrix are equal, then the matrix is called square matrix. So we can see the example in here. We have the matrix A in here. So guys, if you see the rows, also the columns in the matrix is the same, it equals to 3. Since the number of rows and the number of columns are equal, the above matrix A is a square matrix. That's why it's square matrix, because the number of column and row is the same. So guys, it's a wrap. That's the end of my topic today. I hope you guys enjoy it and can understand more matrix from my video, and I hope you like it, and I see you in my next one. Bye guys.